Afternoon all, and today I'm playing with my wearable device project. This is a little device consisting of an Arduino Pro Mini. Most of the pins of that are now used. The little OLED display on which the data is displayed. A battery stack which has a LiPo, also the LiPo on the bottom there, the charger board, and also a little power monitor board using the MAX17043. And now the fourth element, or the final element, is this little nRF24L01 plus data transceiver. And I've got it working, reading 4 fields of data, I0 to I3. I0 is a Boolean, which is just 0 or 1. I'll come back to that. I1 and I2 are reading off the analog inputs of the transmitter, so they're just floating analog values, currently sitting at around 400 or so. And I3 is just an integer, which I'm incrementing constantly, so that will actually roll over when it gets to its highest value. What's that? 32767. Also on the display are the LiPo data. So the Arduino is reading via I2C, that's these two lines here, from the MAX17043 chip, the state of charge of the LiPo. That's what this Max chip does. It calculates the state of charge, and also the battery voltage. So that's the receiver, and now here on the other cutting mat is the transmitter, and this is really simple. This is just an Arduino Uno, a clone, and the nRF24L01 plus transceiver module, and this is plugged in via USB to my PC so that I can modify the code for the transmitter, because it's the transmitter code that I'm particularly interested in just at this moment. So here's the transmitter code, and it is really simple. It is just this page. I've managed to squeeze it in so that there's no scroll bar now. So let's just quickly go through it. Up here are a bunch of includes, SPI for the interface to the transceiver, nRF24L01H and RF24H. A couple of defines to define which pins CE and CSN are on. Those pins could be different. A pipe address, which apparently can be any unique address as long as it's common to the transmitter and the receiver. Then you create the object, the RF24 object, we're calling it radio, and we're giving it the 2 pin numbers, 9 and 10 there. Now I've created an integer array, 4-element array, I've called it I, and I've also created an integer called integer. So in setup, we do a radio begin and a radio open writing pipe, and we specify the pipe there that was created up here. And in the loop, all I'm doing is I'm saying that I1 is analog read A0 and I2 analog read A1, just to give me a couple of data values to transmit. I3 is my integer, which I'm just incrementing all the way up, so it will roll over when it gets to 32767. Now, I0 is 1 if radio write passes, because radio.write, that function, returns a Boolean. And the Boolean is true, or a 1, if the write succeeded, and it's a 0 if the write failed. Well, interestingly, on the receiver, my I0, which is the top element, is constantly a 0. So that's actually telling me that the radio transmitter is saying that it's constantly failing. Well, why is it failing? So here on GitHub, RF24 class reference, and we've got public member functions, and the one I'm interested in is write. So that's this top one here, and that says write to the open writing pipe. Be sure to call open writing pipe first. Well, that's fine, we've done that. And that says this blocks until the message is successfully acknowledged by the receiver or the timeout retransmit maxima are reached. In the current configuration, the max delay here is 60 milliseconds. So if this is failing, it must be either because there's a timeout or there's a retransmit maxima. Now this doesn't actually say how many retransmits it attempts. It does say that the maximum delay is 60 milliseconds, so we must be exceeding that. And here's what the function returns: true if the payload was delivered successfully, false if not. Now unfortunately you don't seem to be able to get any more detail in terms of number of retransmits and the timeout. Well, the timeout would be greater than 60 milliseconds, I guess. So all we have is a true or false. Not really the sort of detail that I would have liked. Now I'm assuming that the reason that this is failing, in other words the reason the transmitter is sending a 0 in the first location of the array, is because the receiver is running so slow, because I'm having to write all that data to the display, and those moving numbers, it's also rewriting the yellow stuff as well, the LiPo, state of charge percentage and voltage. It's writing those constantly as well. They're not moving, but they are being rewritten constantly. So there's a lot going on this display, and I think it's so slow that we're missing data. We're not picking up all the data that the transmitter is actually transmitting. So I figured if I put a delay in the loop, the transmitter's loop, and you can see at the bottom there I've put a delay of just 1 millisecond, that I could slow the whole thing down, because I don't really want to send this data that often. I want to send a packet containing all the data that needs to be transmit, but it only needs to be sent out every, I don't know, half a second or so. So I tried putting a larger delay in there. Let's see what happens. So I tried putting delay of 1 second and half second, but in fact if you just put a delay of 10 milliseconds in that transmit loop, what happens is nothing gets sent. It sends the data once, by the look of it, although the integer there is 10. Actually no, that is 1. That naught at the end is erroneous. So it goes round the loop once, sends a couple of those analog values, and the integer is 1, and then it just stops. It just seizes up. And I'm not quite sure why. So I'm beginning to wonder whether this example code is using these functions correctly, because in setup we're doing a radio begin and a radio open writing pipe, and then in loop we're doing a radio write. But if you put a significant delay in that radio write loop, the whole thing packs up. So I'm just wondering whether to do this properly, if I want to send burst transmissions every 1 second, for example, I'd have to do a radio begin, write my data, and then do whatever the opposite of a radio begin is. I think it's radio stop. Let's have a look. Well, no, it doesn't appear to be that, because there's a radio begin, there's a stop listening and a start listening, but there isn't anything to stop transmitting. There's a begin and there's an open writing pipe and there's a write, and that's it. So what I want to know is, how do you stop transmitting, or how do you transmit infrequently, like once a second? I don't know how to do it. Now if you scroll down below the primary public interface, you get the optional configurators, methods you can use to get or set the configuration of the chip. None are required. Calling begin sets up a reasonable set of defaults. But look at the first one there, void set retries with 2 parameters, delay and count. Set the number and delay of retrials upon failed submit. I wonder if I push those numbers way up, I could get this thing to work transmitting at a much slower rate. Let's give it a try. So in my setup I've now done a radio.set retries 1,000, and so it's 1,000 for the delay, I'm assuming that's milliseconds, and 1,000 for the count, so that's a number of retries, I presume. I've had to put the delay back to 1 millisecond for the loop, but that hasn't really helped, because the first element of my array is still showing a 0, which means that the radio write function is still returning a fail. So that hasn't helped at all. And neither has it helped my transmit loop delay problem, because even with the retries set to 1,000, With a delay of 10 milliseconds in the loop, I'm now back to stuck data. So it's not successfully transmitting anything now. You can see that the integer got up to a 1, that's in the I3 position. So I must admit, I'm baffled. I'm still not fully understanding this RF24 library. I can get it to work, but I don't fully understand how it works. Now look what I found. By clicking on set retries, I've actually got more information on the set retries function. And in fact, it says delay how long to wait between each retry in multiples of 250 microseconds, and the max is 15. So 0 is 250 microseconds, and 15 means 4,000 microseconds, which is only 4 milliseconds. Okay, how many retries before giving up? The maximum is 15. Now 15 retries multiplied by 4 milliseconds is 60 milliseconds, which was apparently what the default was set to. So it looks like the default actually has a number of retries set to the maximum. So I'm not really sure that's going to help. Well, I could try setting it to other numbers, but it doesn't make a lot of sense. Now I can change the data rate because I can set this set data rate function, and I can use RF24_250kbps. It says warning it'll fail for non-plus units, but these are plus units. So let's try that. So in setup I've done a radio set data rate RF24_250kbps, and that's actually caused a fail on the receiver. It's not receiving anything, but I suspect that's because the receiver needs to be set to the same data rate if you're going to do that. Similarly, if you change the transmitter channel, you surely have to set the receiver channel to the same channel. So I'm just going to update the firmware in the receiver to match that data rate and see what happens. So I've got the radio set data rate in both the receiver program and also the transmitter program. I wasn't able to put in the delay 10, that's had to go back to a delay 1, but it is transmitting and it is receiving data on the receiver. But what's interesting, look at the integer, the bottom value. Now I can't see any odd numbers. That looks like it's incrementing 02468. So it's skipping a number. And it's visible now that the data transmission rate is so much slower, and that perhaps explains why I0, which is my parcel fail indicator, is a constant 0, because it's constantly failing every alternate transmission and skipping the integers. So still not quite there with this yet. Got some problems to iron out. So I suppose this is a step forward for the wearables project. It is in a completely standalone form there with its own power supply and transceiver. It is displaying data on the OLED, and I'm sending multiple bytes of data in that packet.